So on last Wednesday, we talked about chemical changes, chemical changes. And somebody actually gave me a new sentence and I wrote it down. I'll find it and show it to you later. But someone gave me a new memory sentence, but the old memory sentence was old grandma's country pies taste lovely. And those were different things that we could look for to know that we had a chemical change. Somebody tell me what those things were that we knew we had a chemical change. Somebody tell me one.
Temperature.
Temperature, a change in temperature, absolutely. If something changes and gets hot or gets cold, then you probably had some type of chemical change. All right, somebody else give me another one.
Odor.
Odor, very nice, all right? Luckily, thank goodness, raw chicken doesn't smell the same as cooked chicken because I don't know if I'd be able to eat it and I like chicken. So, good. So we got temperature change, we got odor. What else do we have?
Color.
Color change. Also, luckily, cooked chicken looks different than raw chicken, okay? Or if I burn something, right, there's a different color. All right, so we got temperature, color, and odor. What else we got?
Gas.
Gas, very nice. Does anybody remember? So most gases though are like clear, like there's gas all around us right now, right? Because hopefully we're all breathing in air. So those are a bunch of different gases. Does anybody remember how do we know if a gas was created if we can't see it?
Bubbles.
Bubbles.
Bubbles, very nice, right? So remember I told you, don't let one rip in the pool because people are gonna go, okay? Because you're gonna see bubbles, all right? So that's gas, temperature, odor. What else are we missing? What else did we say? Did we say color already?
Yeah.
Yes.
Light.
Light, very nice. Thank you, Faith. And then what example did we use for light that we love for celebration?
Fireworks.
Fireworks, very nice. You might think of another one for light. You might see some people at a party, they're raving. You guys even know what that is? No.
LED lights.
Say it. Oh, LED lights, yes, but these you can crack them.
The glow sticks.
Yeah, glow sticks, very nice. All right, so you crack, that's a chemical change. As soon as I pop that glow stick, that's a chemical change and they light up. Those are pretty cool. And then we had one more. It was the weird one that we precipitate. Very nice. All right, so I promise you guys a demo, and I'm gonna do one. Okay. I wish you guys were here. We could do a couple of demos, but that is okay. We're gonna demo. I have to take you guys down off of here. Okay. Take you down. We're traveling. Except for my camera stopped. Okay. Guess what, guys? I have one of my teacher friends is in my room. Look, this is Miss Sandifer. She's in here. She's getting ready for her class too. She's kind of hanging out. You guys can you guys unmute, say hi to her at least?
Hi.
Hi. Hola, señorita.
Oh, hola, señorita. All right, so here we go. Let's see what we got. All right, so we have, I'm gonna put on my gloves because safety first. Unlike the guy who was hacking dry ice with a butcher knife, okay? We practice safety. So I have a liquid, okay? We're gonna learn later on in the year how to name this based off of all these letters and numbers, but this one is called lead 2 nitrate. That's how you would read that. We're gonna learn how to do that later on in the year. And this one is Ki. This is potassium iodide. So 2 liquids, okay? And the liquid, no magic tricks. I don't want you guys to think I'm cheating. All right, so I had some, this is Ki. I had a little bit left over from second block. So I promise you there's nothing else in here though, but a liquid. So I'm showing you there's nothing in here. It's just a liquid, okay? Just a liquid. And then I do have a nice clean test tube for the other one. So here, I'm gonna put some of this one in here. All right, just a little bit, just a little bit, just a little. All right, So we got a little bit of the potassium iodide in there. All right. I want you guys to tell me if you notice any evidence of a chemical change when I mix these two. So I have two liquids. All right. I wish you guys were here because I would just let you pour it. All right. I'm going to pour, I'll pour the clear one in this one. Okay. All right. So here we go. I'm trying to make sure is this focus good? Can you guys see that? Okay, good. All right, here we go. 1, 2, 3. All right, what's the first thing you notice? What happened?
Color.
Yep, color change to yellow. And then I'm gonna see if you guys can see this. Let's see. Give it a second. Notice anything else?
Bubbles.
Can you see bubbles? Maybe. Let's see. I'm trying to focus. See if you can see it this way. Can you see anything now?
One was denser than the other.
Yep.
Two
And
layers.
what else? I heard somebody say something else.
It looks like there's 2 layers.
Yeah, it's 2 layers. And if you, I'm gonna see if I can get a really good shot of it. Let's see if I can move this. Can you see that now?
Yes.
There's a powder in the bottom of it. Can you see it? So like if I turn this to the side, you can kind of see the liquid. And you can see there's a powder in there, okay? So that's a solid. This is an example of a precipitate, right? I mixed 2 liquids together and somehow got a solid. You can kind of see it at the bottom there now, okay? So I'll show you the one from the second block so you can see what it looks like now. So this is the one from second block after it has settled. You can still see the liquid, and then there's a powder at the bottom. So we're going to talk about these type of reactions later on. They're called it's a double replacement, but basically, you know how like we mix maybe like salt and water and it dissolves? Basically, when I mixed these two, some stuff dissolved and some didn't, and so it made a powder. Okay, so that's what it looks like at the bottom. All right, that was that. Our science experiment for the day. This goes back on top. I'm short, so I'm sure on this camera. All right. All right, so now what we're gonna do is, don't want my gloves. So now what we're gonna do is we're going to play Kahoot. Now, I know I don't have to worry about it with this class. However, you know my special second block class, you know they're special. I told them, I said, hey, if you're not playing Kahoot, you need to let me know why. As a matter of fact, I think I'll do Kahoot for a grade, which means if you're playing and you're trying, you get a good grade. And guess what? Probably like half the class still didn't do the Kahoot, so I don't know why. But I know I don't have to worry about that with you guys. So we're going to play Kahoot, okay? There are gonna be some questions on there that you're gonna have to think about because we haven't talked about it, but I wanna see if you can kind of take what you already know and kind of think, okay, well, maybe this, put it together. I think this would happen, okay? And we'll talk about the questions as we go along, all right? So we're gonna do Kahoot for the rest of class. And then for homework, by Wednesday, you have a set of video notes, okay? They're on your calendar and I'll send them out via Remind, but they're video notes. It's 13 minutes and you have to submit a picture of your notes because I want to make sure you guys do it, okay? So once you finish the notes, because the notes are like drawing a diagram. Once you finish that, you just submit. So do it on your notebook, paper, take a picture, upload to Schoology, okay? Any questions about the homework?
Is it gonna be on Edpuzzle?
It is not an Edpuzzle video. I could have done an Edpuzzle. I didn't think about that. I just put it in Schoology. So, but I'll do an Edpuzzle. That might be a good idea. So you can make sure you watch it. I like the way you think, Annis. That's a good idea. I'm going to do an Ed puzzle. So I'll repost it as an Ed puzzle. And then you can just turn in your notes on Schoology. Okay. But the notes is literally just a drawing. Okay. So it's kind of like when you did the America map, but it's a different drawing. And then that's it. We'll pause in the Kahoot if you guys are missing questions. If you have questions on the Kahoot, let me know. I'll be honest, today we've had a little bit of issues with the Kahoot. Like sometimes my Zoomer frees up. So if your computer's going slow or mine's going slow, I'll try to read the questions and the answers in case you can't figure them out, okay? All right, so let me set up Kahoot for us. And then that's what we're doing the rest of the class. Any other questions about the homework? Excellent. Okay, let's see. Why can't I exit the screen? And okay, let's see. All right, here we are. Play now. So another thing is just a thought. I can't give you a grade if, you know, like second period, somebody thought it'd be funny to put your mom. And I'm like, well, I guess your mom would get a grade, but you won't. So just keep that in mind, that I need for you to actually put your name for me to give you a grade. Just a thought, okay? Again, I don't usually have to worry about that with you guys, but just putting it out there. All right, here we go. Let me now share screen. Here we go. Can you guys, let's see if you can see that yet. It's coming. I know you can hear it, but I know you can't see it yet. So hopefully, there we go. I'll give you about, let's say 3 minutes. Not that many of you guys. color change is a color change. So let's see. All right, let's talk about this. So, couple of things. All right, so this is good. Color change. First thing I want you to notice is that I said a color change. So that means something is happening. There is a change, okay? So we should have been at change. Now let me tell you why. I know some of you guys are thinking, why isn't it a physical property? If I just said color, okay? My shirt is blue. The sky is blue. The grass is green. The balloon is red. That is a physical property. But if I said that you had a color change, like what we just did, remember it went from clear to yellow, then that's an indication that you had a chemical change, okay? Now, so the other thing I want you guys to keep up with is if something happened, that's a change, okay? If something happened, it's a change. Otherwise, it would be like a property, like color, okay? When nothing happened, that's a property. Color change, something happened, that's a change, okay? All right, here we go. Next question. See how we did. Very nice. All right, next question. Which one of these are phase changes? Phase changes. Phase. Very nice. Freezing, boiling, melting, condensation. Those are examples of phase changes. Solid, liquid, gas are just states of matter or states of matter. Those are states of matter. No problem. Okay. All right. Next question. This is a little behind mine. Now what? All right. Which state of matter is this? State of matter. About 5 seconds. 4, 3, 2, 1. Okay, so if you have a solid, there's not even going to be, they're going to be literally on top of each other. So all of them would look like these two. They're going to be very, very, very close together. These, they can kind of roll past one another. That's why some of there is a little bit more space in between some of these. So this is actually a liquid, okay? So I think you just, the solid, I think when you see the solid picture, you'll be like, oh, okay, I get it, okay? Here we go. Eric with a streak, very nice. All right, this is one of those I want you to think about. A piece of metal has been heated and it expands. For it to go back to its original size, what do you need to do? If it expands when it gets heated up. Very nice. All right. So this is one of those questions where we hadn't really talked about it yet, but let me give you a quick example, okay? most things, almost everything, when it heats up, it will expand. Okay. So for example, a sidewalk. If you ever notice, remember the whole, what is it, step on a crack, break your mother's back. So there's cracks in a sidewalk, okay? They're actually called expansion joints. If you've ever actually touched the inside of the crack, it's like a rubbery material, okay? Because in the summer, we can't see it because it happens so slow, but concrete expands. And if it expands and it was just one long continuous sidewalk, all the concrete would buckle. And you've probably actually seen sidewalks where they start breaking up and the concrete's pointing up, it's like all cracked. That's because it expanded and there wasn't room for it to expand. So that's why we put cracks in sidewalks, okay? In the winter, it will contract. All right, here we go. This color is a all right, let's see how we did. Did I trick some people? All right, color, just color. My shirt is blue, the balloon is red, is a physical property. Now on this one, I didn't say anything changed. I just said color, so it shouldn't have been changed. And then remember, if my shirt is blue, okay, well, it's a blue shirt. There's nothing, I don't have anything new, so that's not a chemical property. Questions on the difference between those two? Okay. Definite volume, definite shape, so neither one changes. Very nice, very nice. Okay, so fixed and definite mean the same thing. So fixed shape just means it cannot change. Fixed shape means it cannot change. So a solid, the volume stays the same and the shape stays the same. All right. You got a liquid. All the molecules slow down, they make a solid. What's happening in terms of heat? Is it being added or being removed? So this was when we kind of talked about this, but let's think about this. So you got a liquid and the molecules slow down. So you got a liquid and they slow down and form a solid, okay? So you're going from a liquid to a solid. If you go from a liquid to a solid, you have to remove heat. Heat has to be removed, okay? In other words, what's another way I could say remove heat or release heat? What else could I say? Who might tell me?
Melting.
Not the phase change. I just mean if I remove heat, what am I doing essentially? Anybody?
Making it cooler.
I'm making it cooler. Exactly. I'm making it cooler or I'm cooling it off. So if I'm cooling off a liquid to form a solid, I'm going to be releasing heat. Very nice. All right. Here we go. If heat is removed from a liquid, what phase change occurred? It sounds kind of like what we just talked about. So heat removed from a liquid, what phase change? Very nice, very nice. The majority of us got it right. All right, so if I take away heat from a liquid, I'm cooling it down. It's gonna turn into a solid. You can always think about water if you can't think of anything else. So if you cool off water, it's eventually going to freeze. All right, liquid wax drips on a table and turns to a solid. Wax drips on a table and turns into a solid. Seconds, 2, 1. Very nice. All right, let me tell you why I put this question, because a lot of times we say, well, wax is hot. Okay, well, freezing is removing heat. So you got to think about anytime you're removing heat, even if it doesn't feel cold to us, okay, if you're removing heat from a liquid, it is freezing, okay? So that's still freezing, okay? The other way would be melting, but it's gonna be freezing for this one. Very nice, got some streaks going on. All right, here we go. Rusting. Rusting is a, take your time. Make sure you pick correctly, try to. Seconds. Ooh, I got some of you guys. All right, so let's see. No one told me physical change. Very good. And then we have one person who said physical property. Okay, so at least you knew it was chemical. Okay, so most of us knew it was at least chemical. So now the thing is, if I say rusting, is something happening? Okay, and if you answer yes, then that's a change. Okay, now how would I word this if it was a property? I would say the ability to rust. Okay, so it hasn't necessarily happened yet, but it has the ability to rust. That would be a chemical property. So we're getting better though. At least we knew they were both chemicals. So now we just got to remember, usually if you see ing, like something's happening or it ends in change, then it's going to be a change. Okay. All right, here we go. Gas changed to a liquid. What happens to the force of attraction? I gave you a lot of time on this so you can think about it. So gas to a liquid. What do you think is happening to those particles? Are they more attracted to each other or less attracted to each other? Just under 30 seconds. Very good. All right, so this is one of those we didn't talk about. So remember, if you're going from a gas to a liquid, let me ask you this. If you're attracted to someone, do you want to get further away from them or closer to them? You guys tell me. That means you want to get closer to them, okay? So if I go from a gas to a liquid, do those particles get further apart or closer? They probably get closer. So that means the force of attraction increases because now they want to be even closer to each other, okay? So that's what that means. And this is one that we did not talk about. I just wanted you to think through it, okay? So that's good. Ooh, Joe with the streak. Very nice. All right. Oh, we've seen this question before. Let's see. See how everybody does. Oh, we asked it 6 times. 2 seconds. 1. Okay, I wanted this one to be better. I've only asked you this 5 times. Okay, let's see. Let me see how we did though. Dissolving. All right, dissolving. First of all, ing. This should be a change. Yes, it's a change. So it should be either physical change or chemical change. Now remember, I asked you this on your homework. I asked you when we reviewed. You're gonna see it again. You'll probably see it on the test. So at some point, I want everybody to get this right. Dissolving looks and sounds like it is chemical, but it is a physical change. If I add sugar to water, it is now just sugar water. It's water and it's sweet. It is still water and sugar. So it's the same thing. Okay. No new stuff. Okay. That is a physical change. All right. Here we go. Water droplets build up on a cool surface. What phase change is that? Very nice. Condensation, all right? If you're turning into a liquid on a cool surface, you probably came from a gas, so that would be condensation. Okay? Condensation. This is like the water on the side of my cup or the dew on the grass. All right, what happens during evaporation? Am I adding heat or releasing heat? All right, much better, much better. Very nice. For us to do evaporation, okay, heat had to be added or absorbed. Oh, 3 in a row. Very nice. All right, which state? Now think about this. Who has the weakest attraction? Solid, liquid, or gas? What do you think? Think about this. Weakest attraction. Think about if you had a weak attraction to someone. What would you look like? Weakest attraction. Very good. Nice. Almost had 100%. All right, great. Weak attraction, I don't want to be anywhere near you. Okay. So that would be like a gas. Remember, gas particles are super far apart. All right. And solid, so solid would actually have the, what word would I put right here instead of weakest for a solid? What type of attraction?
Strongest.
The strongest force of attraction. Very nice. Strongest force of attraction. That's why they're all up on each other. They're super attracted to each other. All right, which state of matter is this? everybody knew that was a solid. Fantastic. Very nice. Solid. You might know what these little lines represent. What do you think that's trying to
The
show?
vibration.
Very nice. They are vibrating in place. They're moving, but they can't go very far because they're up on each other. Good job. Got a new leader, Dominic. Very nice. If heat is removed from a gas, what phase change? Heat removed from a gas. 10 seconds. Ah, okay, so I got a gas. I take away some heat. That's going to be condensation, all right? So this one, a gas, freezing, remember, has to do with liquids and solids. So it wouldn't be this one. And then this one, boiling, would be you turn into a gas from a liquid. So that would be like if you added heat to a liquid, okay? And that's okay, we're getting practice with these types of questions. So let's see. All right. We'll get through. All right, what state of matter is this? Think about the ones you've already had. Very nice. Now, I'm not surprised some people said liquid, but we already had liquid. Liquids are going to be a little bit closer to this. They're going to be almost touching, but with space that they can move around. So this is a gas. Very nice. Ripping a sheet of paper in half. Ripping a sheet of paper in half. Very nice. All right. So again, here's that ing. So for my two that put property, we again, at least we know it's physical. All right. But this is ing. I'm doing something. So this is a change. Okay. It is physical, but this one's a change because I actually did it. All right. Which state of matter has atoms and molecules that are close together but free to move about? Close together, but they can move. Close together, but they can move about. Ah, very nice. Very nice. So and I tried to say that, I don't know if you answered before I said that, but it's not solid just because these are free to move about. Now, if they were close together and could only vibrate in place, it would be a solid. But these are close together and are free to move about. Okay. I think we got time to get through a few more. We might finish this. Yay. Ooh, think about this one. Read everything before you answer. See if you know what actually happened. Or think about what I said happens to other stuff. This is a really good question. Consider what happens if you, now I'm not going to say anything because then I'll be giving a hint. Got about 20 seconds. 10 seconds. 5 seconds. 3, 2, 2, 1. Ooh, yes, this one was hard. Okay, so here's what I want you to think about. Have you ever put like a can or bottle of soda or water in the freezer? Does it get bigger or does it get smaller? That's what I want you to think about, okay? This is different. Remember I said the sidewalk, most stuff, if you heat it up, it expands. Well, water is the only thing that's kind of different. This one, it expands when it freezes. So it's probably the only substance that does that. That was a tricky question. I probably messed some people up on that one. All right, last couple of questions. I think we can get through. What's going to happen on this one? Think about this. What's going to happen to those particles? They slow down, speed up, does it get bigger, get smaller? Got about 20 seconds. All right. Most of us got that one right. Very nice. So I think about like me, myself. In the winter, I don't want to do anything. I just want to lay on my couch under a blanket. I tend to slow down. But if it's nice and warm or heated, I want to get outside. I want to move around. So molecules are the same way. They will speed up when they get hot. And if they speed up, they bump into each other and they push stuff outwards. So they tend to expand. Very nice. All right. Last couple of questions. We might make it, I don't know if we're going to make it. We'll get at least 2 more in or 1 more. All right. Hands on the stove. It's on the stove and you see bubbles. What's happening? Woohoo! Very nice. It is boiling. Very nice. Okay. Put a pot on the stove. You start seeing those bubbles. It is boiling. Let's try to get 1 more in. 1 more. This will be the last question. We'll miss the last 2. Which state of matter has furthest apart? Oh, we might be able to get another one if we answer this one fast. Furthest apart. Oh, look at those answers flying in. One more. 3 seconds. 2. Oh, yes. Finally. Oh, 100%. Yes. All right. Should we push for 1 more or no? Yes, no, maybe so? All right, last one. We would have got through everything except for 1 question. Flammability. Oh, it's a good one. Flammability. What is it? Yes, chemical property. I didn't say I set it on fire, but it is a property. Very nice. All right, you got somebody on mute. Tell me, do I want to do last question? Yes or no? It's technically in the class.
Yeah.
Yes.
All right, here we go. Last question. Density. Ooh, this is a good one. Density is a so good. You guys are the only class to finish the Kahoot. 3rd place, John C. 2nd place, Fisher and dun, 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 dun. Very nice, Dominic. All right, so quick reminder, your homework is just those video notes. It's only 13 minutes. I already posted it, and I'll post it again as an ed puzzle. And then, that's it. I'll see you guys on Wednesday. Have a lovely day. Bye, guys.
Bye, Miss Payton. Have a great day.
Eric, have a good one. See you guys
Well,
later.
Yeah, see you tomorrow, I guess.
Yes, see you tomorrow.